Let's look at a one-sided hypothesis test for proportion. The probability of a random person being left-handed is about 0.11. We hear that redheads are more likely to be left-handed, so we want to test this hypothesis. The null hypothesis is always no change, no difference. That's represented by h sub 0 or h naught. And it always has an equal sign, so it's of the form p equals p sub 0. The alternative hypothesis is that there is a change, there is a difference. We represent that with h sub a or h sub 1, and the alternative hypothesis has a not equal sign or a less than sign or a greater than sign. It's of the form p does not equal p sub 0, p is greater than p sub 0, or p is less than p sub 0. Okay, the hypothesis that we want to test is h sub 0. The probability of a redhead being left-handed is 0.11. That would be our, well, that would be our null hypothesis, really. No difference, all the same. Redheads, nah, they're no more or less likely to be left-handed. A way to represent this symbolically would be let p equal the probability of a redhead being left-handed. H sub 0, p equals 0.11. Now, there are different possibilities for the alternative hypothesis. P does not equal 0.11. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the probability of being a redhead being left-handed is different from 0.11. Or if we wanted to test the hypothesis that the probability of a redhead being left-handed is 0.11. Either case. That's not what we have here. P is less than 0.11. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the probability of a redhead being left-handed is less than 0.11. Not what we have here. P is greater than 0.11. We would choose this as the alternative hypothesis if we wanted to test the hypothesis that the probability of a redhead being left-handed is greater than 0.11. That's what we've got in this case. We choose this as the alternative hypothesis because we want to test the hypothesis that the probability of a redhead being left-handed is greater than 0.11. Okay, let P be the probability of a redhead being left-handed. There is our null hypothesis, P equals 0.11. The alternative hypothesis is one-sided. P is greater than 0.11. I was unable to find actual data for this problem. Sorry about that. But suppose we survey 1,000 redheads and find that 140 of them are left-handed. Test the hypothesis that redheads are more likely to be left-handed. Okay, there's null and alternative hypotheses. Calculate the test statistic as Z. Here, P hat is a proportion of successes in the trials. We had n equals 1,000 redheads and 140 of them were left-handed. So P hat, the proportion of success, would be 140 over 1,000. P0 is the conjectured value of P in the null hypothesis. That is 0.11. Okay, let's go ahead and plug those in. Z equals P hat minus P sub 0, so that's 140 over 1,000 minus 0.11. All over the square root of P sub 0, that's 0.11, times 1 minus P sub 0 over n over 1,000. That works out to be 3.032. What does that mean? Z equals 3.032 is our z-score. Assuming the null hypothesis is true, this is what the distribution of z-scores would look like. It's normal with mean 0 and standard deviation 1. We've seen this distribution before, the normal distribution. When the alternative hypothesis is two-sided, not what we have in this case, we reject the null hypothesis when the z-score is too far to the left or too far to the right. So in other words, when z is less than negative 1.96 or z is greater than 1.96, when the alternative hypothesis is two-sided. When the alternative hypothesis is one-sided, and if the form P is less than P0, not what we have in this case, we reject the null hypothesis when the z-score is too far to the left. Why only to the left? There is no need to embrace the alternative hypothesis P is less than P0 if our data indicate a value of P which is much greater than P sub 0. So if you get a z-score way out here, which corresponds to a large value of P, you're not going to embrace that alternative hypothesis, which says that P is small. P is less than P sub 0. You would only embrace this alternative hypothesis if you get a really small value of P, so something out here. So thus, since the default level of confidence is 95%, we reject the null hypothesis when the z-score is in the bottom 5%. So if you get a z-score over here that's when you reject the null hypothesis. This means we reject the null hypothesis when the z-score z is less than negative 1.645, because that's the bottom 5%. Z is less than negative 1.645. When the alternative hypothesis is two-sided, recall that we reject the null hypothesis when z is greater than, or when z is less than negative 1.96, okay, or z is greater than 1.96, because those regions correspond to the bottom 2.5%, that's 2.5%, or the top 2.5%, okay, and those add up to 5%. So we're looking for a 5% rejection region. We want 95% confidence. Similarly, when the alternative hypothesis is one-sided, and if the form P is greater than P0, that's what we have in our case, we reject the null hypothesis when the z-score is too far to the right, because there's no need to embrace the alternative hypothesis P is greater than P0 if our data indicate a value of P, which is much smaller than P0. So if you get a really small value of P, which corresponds to a really small z-score, you get something in this case over here. But you're not going to, you're not going to embrace that alternative hypothesis, P is greater than P0. You're going to embrace that only when you get a big value of P. And we don't have that when we get a z-score over here, when P is small. Since the default level of confidence is 95%, we reject the null hypothesis when the z-score is in the top 5%. This means we reject the null hypothesis when the z-score, z, is greater than 1.645. So again, that's assuming that one-sided P is greater than P sub 0 alternative hypothesis. Okay, to summarize, if the alternative hypothesis is P does not equal P sub 0, that's the two-sided alternative hypothesis, these would be our rejection regions. Z is less than negative 1.6, Z is greater than 1.96. If you have an alternative hypothesis like this, P is less than P sub 0, your rejection region would be Z is less than negative 1.645, because you'd end up with a situation like this. You want low values of P. That's when you'd reject the null hypothesis. If, on the other hand, the alternative hypothesis is P is greater than P sub 0, then the rejection region is Z is greater than 1.645. You would reject it only if you get a big value of P, which corresponds to a big value of Z. Since our alternative hypothesis is one-sided, and if the form P is greater than P sub 0, we reject the null hypothesis if the z-score is too far to the right. So in other words, if z is greater than 1.645. Our z-score is 3.032, which is greater than 1.645. We conclude that the null hypothesis is false. We reject that null hypothesis. Find the p-value. What's the p-value? This is short for the probability value. It's the probability that we would get a result this extreme, or even more extreme, if the null hypothesis were true. If the null hypothesis were true, the probability that we would get a z-score of 3.032 or even more extreme is, okay, we enter normal CDF, A, B, mu, sigma. In other words, enter normal CDF 3.032, 10. And we get 0.0012. That's the p-value. Because again, we want to know the probability that we get a result even more extreme than our z-score. And the probability to get a result even more extreme, that's just going to be to the right of our z-score. If the alternative hypothesis H sub A, again, this is the situation we had here, P is greater than P sub 0, then the p-value is going to be the area to the right of Z. Because this is the situation we have. The alternative hypothesis P is greater than P sub 0, you would, so the probability to get a result that extreme or even more extreme, that's the area to the right of Z. If your alternative hypothesis P is less than P sub 0, the p-value is the area to the left of Z. And if your alternative hypothesis P does not equal P sub 0, it's twice the area to the right of the absolute value of Z, because that's the probability to get a result that extreme or even more extreme. So our p-value is 0.0012. If p-value is less than 0.05, we reject the null hypothesis because there's less than a 5% chance that we would obtain a result this extreme or even more extreme if the null hypothesis were true. If the p is low, the null must go. That's what we have in our situation. P equals 0.0012. That null is gone. So again, P is the probability of redhead being left-handed. There's our null and alternative hypotheses. We reject the null hypothesis and conclude that the probability of a redhead being left-handed is greater than 0.11. By the way, men are more likely to be left-handed than women. A meta-analysis of 144 studies totaling n equals 1,787,629 participants indicated the males were about 1.23 times as likely to be left-handed.